In this problem, I will go over the theory for solving Newton's second law problems with an air resistance that has dominant term the linear term. So I'm going to start with Newton's second law. The net force dp of the system over dt, and if I make the assumption that the relativistic factor is roughly 1, this gives me a net force that is proportional, that is approximately equal to the mass times the acceleration. Now this is a vector, and I can write mass times dv over dt, or mass, then the vector dvx over dt, dvy over dt, comma dvz over dt. Okay, depending on the problem, of course, I have chosen here the Cartesian coordinate system because this is what makes my life the easiest for this problem. But for other problems, you will need to think about what coordinate system you need to use. Now, I have written this expression for acceleration. I have the net force equals mass times the vector dvx over dt, dvy over dt, and so on. And now I need to look. I need to look at the interactions and the forces, and find the net force. Now I am talking about the projectile that is moving through the air. So let's say I have my object, and it does have a gravitational interaction with the earth. And it also has a contact interaction with the air. Okay, and as my system, I am choosing just the projectile, just the object. Now, the net force will be the gravitational force from the earth on the object, and it will also be that contact force from the air on the object. Now, the gravitational one is 0 minus mg 0. And the way, when I only take into account the linear term, that contact force will be equal to minus b times v. Now I'm gonna write it a little bit better. Vx, vy, and vz. And because I have the sum of those two vectors, it will give me 0 minus bvx minus mg minus b vy, and then minus b vz. This is, I want to remind you, this is equal to the net force. And what I did here, I looked at the interactions that my system has with the surroundings, and I know the expression for those two forces, and I was able to find the net force just by looking at the interaction. Now, let's call this equation 1, and this is equation 2. If you look at this, both equations 1 and 2 are equal to the net force. Both of them talk about the net force. Now, I obtained them in a different way. This came from Newton's second law, the physics principle that relates interactions in motion but I got this just by looking at the interactions. So I'm gonna set them equal to each other because they are talking about the same thing, the net force. So from 1 and 2, I get the following. The mass times dvx dt, comma, the same thing, comma, dvz dt is equal to what I found for the net force before, minus bvx minus mg minus bvy and minus bvz. Now this is a vector equation. Okay, so I have a vector on the left side, I have a vector on the right side, and this equation is telling me that the vector on the left side is equal to the vector on the right side. For this to be true, every component of the vector on the left side needs to be equal to the same component of the vector on the right side. So this expression, this one single equality, is gonna give me three equalities, one for each component, the x, the y, and the z. So for the x, I have m dvx over dt is equal to minus bvx. In the y, I have m dvy over dt is equal to minus mg minus vy. This is vy, and in the z, m dvz over dt is equal to minus bvz. Now one thing you can pay attention here, the equation for x and z, they are similar. They are actually, if you change x for z, you get exactly the same thing. So what I need to do when I solve these equations, I will only solve the x, and then whatever I get for x, I know my solutions are gonna be similar for z. Just change x to z and you got your answers. So this single vector equation became three equations, one for each component, and I will need to solve them to obtain the equations of motion. Now for equations of motion, I need to get, okay, this is my goal, I need to have ax, vx, and x, ay, vy, and y, and the same thing in the z. As I said though, I will only work on x, and of course I need to work on y. Y is fairly different than x, and then whatever you get for x, you get the same thing in the z. Now from here, of course, I do know what the acceleration in the x is. I can solve for acceleration in the x, and it will be a function of vx, and if I solve for the acceleration in the y, it will be a function of y. So actually, before I finish this, I will write it down just so I know. Ax is minus b over m vx. I'm not done yet with acceleration. I will need to come back to this. Ay is minus g minus b over m vy. Okay, I will come back to these two at the end to find the acceleration. So now I need to start thinking about solving these differential equations. And I will add one more board so that I can do this. I'm going to start in the x. I had m dvx over dt is equal to minus b vx. The way that we can solve relatively simple differential equations like this one, I will try to isolate every variable on a different side. So I have Vx and time. I'm gonna move everything about Vx on the left side, and I'm gonna move time to the right side. So this is gonna become m dvx over Vx equals minus b dt. Now I have done that. I will also move the mass on the right side, just so it makes my life a little bit easier when I do the integration. I will only have to worry about this on one side. Okay, now I have everything on the left side is about velocity, everything on the right side is about time. I will integrate. Now, for the limits of integration, I will just use a variable. I don't know what will be the Vx initial. I will just say whatever it is, that's what it is, and the symbol I'm going to use is Vx initial. And for final, I'm going to have Vx. Now, it is important to remember that from mathematics, we cannot use the same symbol as a variable for integration and as a limit. So what I'm going to do, I'm going to put the prime here so that I'm okay with that. And also I will integrate time. Time will go from 0, say, to t. And again, these two cannot be the same, so I'm going to use a prime here. Now, the integral of 1 over x is just the natural log of Vx prime. And when that goes from Vx initial to Vx, and this will simply give me minus b over m t prime when that goes from 0 to t. And then I have ln of Vx minus ln of Vx initial. And the right side is just minus b over m t minus 0. I'm going to leave the 0 out. And moving on. Now, whenever you subtract two natural logs, you can do ln of Vx over Vx initial. This is a property of the natural log, or of logarithms in general. This is minus b over mt. Now I will get rid of the natural log, so I will have Vx over Vx initial. And this, to get rid of the natural log, I need to do e to the minus b over mt. And I'm going to solve for Vx. This is Vx as a function of time, equals to Vx initial e to the minus b over m time. This is the equation that I was looking for. Okay, for Vx as a function of time. Now that I have that, the equation for Vx, I can also move on and say, well, I know that Vx is dx over dt. So I can say dx over dt is equal to Vx initial e to the minus b over mt. And I'm going to follow a similar process as I did before. I will isolate everything about x is going to be on the left side. Everything about time is going to be on the right side. So I will have dx is equal to Vx initial e to the minus b over m time dt. And again, I will integrate. So this goes from x initial to x, my final, as a function of time. I put the prime here, make sure I'm okay. Time goes from 0 to t, and I put a prime here just so I'm okay mathematically speaking. And now I move on with my integration. X prime will go from x initial to x, and I'm gonna say this is just x minus x initial, and then the right side, vx initial is a constant, and I need to multiply this with minus m over b e to the minus b over m t prime when time goes from 0 to t. Moving on, I have x minus x initial minus m over b vx initial e. Okay, so here I need to use parentheses, minus b over mt. There is a, let me make it clear, there is a minus. Okay, this here is a minus. And then minus e to the minus bm times 0. Now e to the 0 is just 1. So the whole thing here, this is 1. This becomes minus m over b vx initial e to the minus b over m time minus 1. And this is, I now have the equation for x as a function of time. It is equal to x initial. And one thing I can do, I can get rid of the minus sign, plus m over b times vx initial. It will be 1 minus e to the minus bm times t. And this is the equation in the x direction. I would like to show you really quick how those two quantities behave as a function of time. Fairly easy to see. So from the expression about the velocity, the vx, I know that as time goes by, as time increases, e to the minus the large number here, the exponential will become smaller and smaller. So, and at t equals 0, this is 1, so my vx initial, of course, is my vx initial. So if you say this is your vx initial, I know that at the end, because I have e to the minus a large number, I know that my velocity will be approaching 0. And this is what it will be approaching 0, and this is what the graph will look like for vx. Now, for x time, of course, I start from x initial. Now, when t is 0, this is 1, so this goes to 0, x equals x initial, as I mentioned that. Now, when t becomes large, like a large number, e to the minus a large number again becomes very small. 1 minus a very small number is equal to 1. So x initial plus this is going to be a number, a constant if you want. Your value for x is going to be approaching that one. This is x initial plus m over b v x initial. Okay, whatever that is. depends on the problem, but your x is going to be approaching that one as time goes by, and at the limit of t goes to infinity, the value of x will become this one. So this is the solution for in the x direction. And now moving on with the y, I will talk a little bit about that. M dvy dt minus mg minus b vy. I will follow the same process as before. I will need to isolate everything about velocity on the left side and everything about time on the right side. Now the way that I'm going to do that, first I'm going to divide everything with m. So then I'm going to have dvy over g plus bm vy, and I'm gonna leave minus dt on the right side. Now I will integrate. This goes from vy initial to vy, and I need to use a prime here, and this goes from 0 to t, and I will use a prime here. Now the function that I need to use, since it is of the form of 1 over dvy prime over vy prime, I know that my function is going to be a natural log t plus b m vy prime, and this needs to go from vy initial to vy. Now you can also use substitution to see this, but because this is a function of a function, when you take the derivative of this, you do have a factor of b over m, so I will need to multiply this with m over b. If you're not comfortable with this, feel free to use substitution to see how that shows up. And then this is equal to minus t prime from 0 to t. Alright, I continue to have m over b, open parentheses, ln of g plus b over m vy minus ln of g plus b over m vy initial. Let's make this a bracket, and this is I'm gonna work on this for a little bit. M over b ln, okay, I'm gonna do the same thing as I did in the x direction. I'm gonna say g plus bm vy g plus b m vy initial, and this is equal to minus t. I will move m over b to the other side, and then I'm gonna get rid of the natural log, so I have the fraction g plus b over m vy over g plus bm vy initial. Okay, so what I'm doing here, I got rid of the natural log, so I have the exponential, and I moved over the m over b, so I have minus b over m times time, and now I will rearrange these things. Vy is equal to g plus b over m vy initial, times the exponential, and I will move g to the other side and multiply with m over b. So I will have vy. Okay, so I am multiplying with m over b, g plus b over m, vy initial, e to the minus b over m t. And remember, I brought g, so minus g, and I also multiplied with m over b. I will write this a little bit better. Vy as a function of time is going to be m over b times g, parentheses. The m over b with the b over m will cancel out, so I will have plus vy initial, and this is multiplied with the exponential, and then I have minus m over b times g, and this is the expression for vy. Took me a little bit of time, but can be done. You just need to be careful with the integration. And now, as I did before for x, to find x as a function of time, you can follow through the same process. Okay, you will need to say dy over dt is equal to vy, which is what I found here. I'm going to leave it as an exercise for you to work out what you get for y as a function of time. Okay, this last one will be, it will take you, it will require some work to obtain the y as a function of time, but the process is exactly the same. Just be careful with the integration and moving stuff around. This is the process for how you will use linear air resistance term in Newton's second law and how you will be solving these problems.